Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to lecture 21, Organic Chemistry 1. Today we will continue on chapter 6, Stereochemistry. Enantiomers. When a compound is chiral, it will have one non-superimposable mirror image called its enantiomer, from the Greek word meaning opposite. The compound and its mirror image are said to be a pair of enantiomers. Here we have a chiral compound with center carrying four different groups: purple, green, red, and white. Its mirror image will be a compound called its enantiomer. Okay? And these two enantiomers are not superimposable. Here we have compound A. This is a chiral center carrying four different groups. Here we have its mirror image B. So this compound is enantiomer with the opposite configuration. I would like you to watch carefully. When we switch, we take B and switch the green with white. So end up with this compound. I switched the green and the white. So the white and the green. And then we rotate the molecule. So the red will be on this side. We will find the green became in this side, and the white will be on this side. And now both molecules are superimposable. They are the same compound. So when we took the enantiomer, make odd switch, we get the original compound. Interchanging any two substituent on the asymmetric carbon atom once or odd number inverts its configuration. Okay, if we do the switch even number, so we get the same compound, not its enantiomer. Okay? If we took B and make two switches, we get B. But when we did it once, we transferred B to A. Okay? Here we have alanine compound with chiral center, and this is its enantiomer. Here we have bicyclic compound with three chiral centers, and this is its enantiomer, its mirror image. Here is center. Here is 1, 2, 3. In order to communicate more effectively, we need system of nomenclature for identifying each enantiomer individually. So three scientists, Cahn-Ingold, and Prelog, they designate conformation system for naming this chiral molecule. To determine the name, we follow two steps. Procedure that assign priorities to the four substituent and then assign the name based on the relative position of this substituent. The first step of this system involves assigning priorities to each of the four groups attached to the chirality center based on atomic number. After assigning priorities to the four groups, we then rotate the molecule so that the fourth priority is in the back, behind, or what we call it the dash when we draw the 3D structure. Then we look to see if the sequence 1, 2, 3 is clockwise, then it's R. If it's counterclockwise, then it is an S configuration. For this compound with this chiral, Br atomic number is higher than the nitrogen, and nitrogen is higher than the carbon, and the hydrogen is the lowest. So hydrogen, okay, it's in the back. So we have Br number 1, H2 number 2, CH3 number 3. Moving from 1 to 2, we are going this way, right? So it's counter or anti-clockwise from 2 to 3 this way. So now it's clear. So this has an S configuration. This chiral center has S configuration. Now, one more time. Here is 1, here is 2, here is 3. From 1 to 2, it's counterclockwise S. Now we check on it's an enantiomer. It's mirror image. Br will be on the right hand, so it's 1. NH2 will be on the left, that's 2. We are moving the other way around. So it's R configuration. Now we can differentiate and we can name the enantiomers correctly. If it's more complicated, how to assign the priority according to the atomic number. So iodine will be higher in priority than bromine, than chlorine, iodine, bromine, chlorine, sulfur, fluorine, oxygen, nitrogen, carbon, and lithium, and then the last one will be hydrogen. Iodine, bromine, higher than chlorine, then sulfur, sulfur more senior than fluorine, then oxygen, then nitrogen, then carbon, then lithium, then hydrogen. If we look for the isotopes, the higher the isotope will have the high priority. Carbon 13 will be more senior than carbon 12. Hydrogen 3, higher impurity than deuterium. Hydrogen 2, then H1. Okay? Getting complicated. Which one is senior? CH2, CH2Br, or CH2, CH3? Now, this is adjacent to the chiral, link it to the chiral center, okay? Now, from the chiral center, the group is carbon, 2 hydrogen in here, hydrogen, hydrogen, and then carbon, okay, carbon, and then Br. Let's check this one. They are even here. Carbon, here is carbon. Carbon, here is carbon. But now, tie break with the bromine in here and hydrogen in here. So which one is senior? This group is senior. All right. CH2 Br. Okay, this is carbon. Has 2 hydrogens and 1 Br. This is carbon, CHCl2, has a hydrogen but has Cl, which is senior, Br. So this is a tie break, Br and Cl. Here, carbon carrying carbon, CH3 tertiary butyl. So this is carbon carrying carbon, carbon, carbon. I compare it to CH carrying CH3 and carrying CH2 Br. So this carbon is carrying carbon, carbon, and H. Here I have carbon, another carbon, another carbon, third. Here I have carbon, carbon, and H, which is senior. So the break tie is this carbon. Okay? Treat double bond and triple bonds as if each were a bond to a separate atoms. For the carbon double bond carbon, if this is a chiral center in here, this carbon is connected to 2 carbons, and this carbon is connected to 2 carbons, and then the first one connected to 1 hydrogen, second one is connected to 2 hydrogens. For the carbon triple bond carbon, this carbon is connected to 1, 2, 3 carbons, 1, 2, 3, and this carbon is connected again to 3, 1, 2, 3, and then 1 hydrogen. For the imine group, this carbon is connected to 2 nitrogens, and this nitrogen is connected to 2 carbons, and then hydrogen for this one and hydrogen for that one. For the carboxylic group, this carbon is connected twice with this oxygen, once with this one, so 3 oxygen total, and this oxygen is connected to 2 carbons, the structures of the enantiomers of carbon are below. A carbon is naturally occurring compounds. One enantiomer responsible for the odor of caraway seeds, the other for the odor of peppermint. Find the asymmetric carbon atoms and determine which of them are NS configuration. This is the asymmetric carbon, and this is the asymmetric carbon of the mirror image. We call it enantiomer. Okay, let's arrange the priority. This group here, the carbon is connected, is part of double bond, so it's connected to 2 carbon, and then one carbon in here, so 3 carbons. This carbon will be connected twice to carbon, so it's connected twice to carbon. Let's go to carbon 2. It has 2 hydrogens, and then carbon connected twice to oxygen, and 1 carbon, twice 1 to carbon and twice to oxygen, and the oxygen twice to carbon. Let's go to the third group, carbon carrying 2 hydrogen and 1 carbon. This carbon is belong to alkene, so it is connected twice to carbon. It has 1 hydrogen, and this carbon is connected twice to carbon. According to the priority, so number 1 is senior, carbon, 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 while here is carbon, hydrogen, hydrogen. So this is number 1. Now, this carbon here connected to hydrogen, hydrogen, carbon, hydrogen, hydrogen, carbon. They are the same. So we have to go forward. And this carbon is connected twice to oxygen. This is twice to carbon. So this is number 2, and this is number 3. If that is the case, looking how we get from 1 to 2, anti-clockwise or counterclockwise, so this has S configuration, and the mirror, of course, will have the R configuration. Star each of the asymmetric carbon atom in the following example and determine whether it has R or S configuration. This molecule has only 1 asymmetric carbon, and we have here O, and then carbon, carbon, and carbon, hydrogen. So this will be number 1, this will be number 2, and this will be number 3. To name it, according to the rule, the hydrogen should be in the back. So what about switching 4 and 1? That will give us this enantiomer of that. H is in the back, 1 is here, 2, 3. So we go this way. It is counterclockwise. So this enantiomer is S. So this one will be R. Alright? We did the switching once, odd number. If we do it one more time, then we will get back to the same enantiomer. We will come back to this enantiomer. Maybe it's different in space, but it is the same compound. Switch 2 with 1. Then you get 1, 2, 3. 1, 2, 3. This is clockwise. Here the hydrogen in the back. Okay, 1, 2, 3, R. So that's right. That's right. It's R configuration. For this molecule 3,4-dimethyl pent 1-ene, we check for this carbon has two methyl group identical, so this is not a symmetric carbon. For this carbon carries carbon double bond carbon, that's one, isopropyl group, that's two, methyl group, that's three, hydrogen, four different atoms. This is a symmetric carbon. If we look for carbon, the vinyl group, which we gave it number one, we find that this carbon has double bond carbon, so carries two carbon, and this carbon carries two carbon, one, two. So this is right. For two carbon carries two methyl group and one hydrogen, so one hydrogen, two carbons. And this is CH3, carries three hydrogens. So this group will be number one, this is number two, and this is number three. And number four, the lowest in purity, is on the back already. So four in the back, this is a symmetric carbon, and here 1 to 2, 2 to 3, it is going clockwise, so this is R configuration. This center is R configuration. For the second molecule, this is chiral, this is a symmetric center, right? Hydrogen in the back, this group is number one, again carbon carries one hydrogen and two carbons, and these carbons, because of the double bond, carries two carbon. Okay, one here, one here. If we need the third one, because there is one in here, we will check it. Okay, so this is carbon, 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 carbon. Look, this carbon has two hydrogen and one carbon, and this carbon carries two carbons. Let's go and check. This carbon carries two hydrogens and one carbon. This carbon carries two carbons. Third group, carbon carrying two hydrogens and one carbon. And this carbon carrying only one carbon. If we compare, this is carbon, 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 hydrogen, 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 carbon, hydrogen, hydrogen, carbon. This is hydrogen, carbon, since this is number one. Now compare these two. This is carbon, has two hydrogens, but while this one hydrogen and two carbons. So this is number two and this is number three. So number 1, 2, 3, rotation is going counterclockwise, so it is S configuration. Let's see the other asymmetric carbon, where the hydrogen is up the plane in front. Okay, so we have to rotate it 180. That makes the 3 from left to right and 1 from right to left. Okay, rotating will 1, 2, 3 will be clockwise, and this is R configuration. So it's 1R, 4S bicyclo, 2.2.1 heft 2-in compound. And if you can see that there is a plane of symmetry, so if this carbon S, the mirror here will be R. So this is just to confirm the structure. This is R. Now, for this particular molecule, this is a chiral center, carries 4 different groups. For this one, carbon carrying hydrogen and 2 O carbon. So it's carrying hydrogens and 2 O carbons. For the aldehyde, this is carbon, oxygen, oxygen, and the oxygen here carries 2 carbon. This is aldehyde. So looking for this one and this one, this is more senior. This is 1, this is will be 2. Check the third one and the fourth. This one is carbon carrying hydrogen and 2 carbons. Carbon and carbon. And this carbon carry 2 carbons, carbon and carbon. So this is how we look for the vinyl group. For this one, will be carbon carrying hydrogen and 2 carbons. And that's it. So this will be more senior than this one. Accordingly, we have here 1, 2, 3, 4. 4 now in front, it has to be in the back. So we rotate 180, see how it looks like. It will be 1 up as it is, 1 will be from left to right, and the third one from right to left, and the least number 4 will be in the back. This is the least number 4, least in priority will be in the back. Now that's it. Okay, now we look at about the going from 1 to 2. From 1 to 2 is counterclockwise, right? So this configuration of this carbon is an S configuration. Okay? Recall the beginning of the lecture. We have given these 2 structure with question mark asking about the configurations of these molecules. Now we know how to name it. So for this compound, we have nitrogen, we have carbon carrying oxygens, and we have carbon carrying hydrogens. So nitrogen would be the first in priority. This is would be number 2, and this is would be number 3. And going from 1 to 2 will be counterclockwise. So the name will be S. 2-amino propanoic acid. Let's go for this one. This compound has 3 chiral centers. Naming the compound, this will be 1, 2, 3, 4, 5, 6, and this is number 7. Let's start assigning carbon 1. Carbon number 1, the hydrogen will be in front. Okay, so we have to rotate it 180. and this will be the structure. This will rotate this 180, so this will be going from right hand side to the left hand side, carbon carrying 2 bromine and hydrogen, and this will be from left to right. Here is CH2, CH2, and then this bridge, carbon carrying 2 hydrogen and then carbon. So according to the priority, okay, this will be number 1. The bridged carbon, CH2, carbon, carbon, carbon. This will be number 2. And this will be number 3. We are going here clockwise. That's why carbon number 1 will be R. Let's look for carbon 2. Now its hydrogen is in the back. Here is the hydrogen. Br number 1 will be 1. Then you have CH2, then carbon, carbon. So this one will be number 2. And this will be number 3. Accordingly, going 1 to 2, 2 to 3, it is counterclockwise. So 2 will be S. For number 4, already hydrogen in the back. This group CH2, here is CH2, here is CH2. This is first. Then carbon Br. So this will be number 1 in priority. Now, this is carbon, carbon carrying 2 carbons. So this will be number 2. This is carbon carrying carbon, but this carbon carrying 2 hydrogens. So this is number 3. 1, 2, 3 is again counterclockwise, so it's an S. So the name of this molecule will be 1R, 2S, 4S, between brackets, hyphenated, 2 hyphen, bromo bicyclo, brackets, 2.2.1, bracket, close the bracket, heptane, 7 carbons. These are the asymmetric carbons, 1 and 2 and 4. I hope that you have enjoyed the lecture. See you in the coming one.